So let's continue on with this question 5. We just wanted to make it separate. Right, if you look at the previous questions, this one, and this one, they're the same. So if you can learn one, you can work out what they want from you from here. So they've got a cell. Cell is a single. Yeah, remember, cell is single. Battery is more than single. Then you've got a variable resistor. So remember we said it's like a rectangle with a line through it. Ammeter, voltmeter, and a filament lamp. You'll get used to these, you just got to keep practicing them. Right, okay. Start with the cell or the battery. Remember the long side is plus, the long side is plus, the short side is minus. So they've not said, they've not used a switch, so we'll ignore the switch. So on this side we always put the ammeter. Right, it comes across here. We can stick in a variable resistor here to vary the voltage across it, and also the filament lamp. What have they called it? Filament lamp, yeah. And then you go back up. There's nothing else that they've told us to link, so we can close that up. And then we need one more thing, which is the voltmeter. The voltmeter always goes across the component that you want, so just stick a little V here, across here, there, it joins there. Done. That'll give you 4 marks. So let me highlight this. The ammeter is in series, the voltmeter is in parallel, because look, these two lines are parallel. There you go. Right, now we've got to draw this. How do you draw this? You've got voltage and current, right? Okay. It's clever the way they've done it, yeah, but they've actually given you the labels. So always have the current here. If they don't give you the label, always have the current. Because remember, V equals IR. V divided by I equals R. This, in effect, is the resistance, the gradient. Right, so it's showing draw best fit curve. So how are we gonna, right, we're gonna have to just bear with me 1 second. Right, let's crack on. So at 0, 0, what color am I using? Yeah, that's fair enough. 0, 0, and then it's at 1, 0.3 at 1, 0.38 is there, and then 2, 0.61 at 2. At 2, we go to 0.61, so 0.6 is there, 0.62, so 0.61 will be halfway between, right? And then we're looking at 3, 0.8, so we go to 3, 0.8, that's the easy one. And then we go to 4, 0.9, 4, the voltage is 4, we go 0.9, that's quite straightforward. Then we go to 5, 0.96. So we go to 5, 0.9246. You've got to get used to the scales. Oh, that's a bit out. Right, and then 6 and 1. 6 and 1 is easy. Now they want you to draw a curve of best fit. Right, so you get a pencil and you do something like this. Oh, that's quite nice. I normally get that wrong, but okay, it's done. Good. Right. The filament of a lamp is made of metal. The student suggests that a straight line on the graph is more appropriate than a curve because current is directly proportional to voltage for a metal. Suggests how the student could improve the investigation to find out whether a straight line or curve is more appropriate. Right. Why would he say that? How can you improve that? Right. Okay, what he could do is maybe, okay, according to the mark scheme is the student could take more data at different voltages, so you can vary the voltage even more. Take the at different voltages. Explain why the student should not expect the current to be proportional. Right, it's because as the current flowing through it increases, the temperature increases, so therefore the resistance increases, so therefore it reduces the current. Right, so what we can do here is the current will heat up the filament, so resistance changes with temperature. And if resistance changes, the gradient changes. So change in resistance changes the gradient of the graph. So there's just 3 points that you can make or learn. So as the current change, right, let me write this. As the current changes, the resistance changes. As the resistance changes, the gradient will change. So this is what's happening. As the current is increasing here, right, the resistance is increasing, and so if you've got the lower the gradient, the higher the resistance. Just remember that. That's what it is. Let's just leave it at that. Okay, let's try to see if we can get question 6 in. Right, so this is not, well, it is down here. This is the electricity question, but let's look at this best we can. So have you noticed you've got a plastic case, and here you've got an aluminium case. Plastics are good insulators. you've got hot air rising, so we're expecting convection. You've got heat being transferred, and then via conduction out of the computer. Here you've got heat being transferred via convection because the fan pulls out and aids the convection. Convection is the actual physical movement of particles. This here will be conduction. And does it say anything? Right, white. Right, this is black. This is black in color. So if it's black in color, it's going to be a good emitter. It's going to be a good emitter of radiation. So it's going to emit heat. And it's going to radiate heat as well. This is white. It's a white case, so it's going to be a poor emitter of radiation and heat. Right, so we need to explain the main method of heat transfer for case X. So let's just get that. We'll answer that here. So the main method of heat transfer is convection, right? And the fan, the fact that the fan is on is the fan helps convection, in this case convection or heat transfer. Right, because it's plastic is a good insulator and a poor conductor. So conduction is minimal or does not occur. It's not the main one. So conduction, not main method of transfer, not main way to transfer energy or heat. Right. What else can we say? Right, they also mentioned that it's a white plastic. So the white plastic is a poor emitter. So you will not lose heat via radiation. Is a poor emitter of infrared radiation of energy. Okay, now they're asking you to explain. So it's basically it's the opposite. It's just using really the opposite. But the other thing is, look, if you do get any convection, it's just going to circulate around in here. You might get some transfer there, but minimal. So, but the main one is through this block here, metal block. So you got conduction through there, and then because that's metal as well, the aluminium case will conduct heat, and then you'll get radiation and a bit of convection. It'll be mainly conduction. So we've got to write that down somehow. Where do we start though? So the main method is conduction. Okay. Convection is the movement of particles. So where you've got the particles are moving and moving the energy. But conduction is where through vibration they pass on the energy to the next particle, Right. Why is it? Because metals are good conductors of energy or heat. Right, we've said, right, we need to say that. We've said like convection is going to occur, but it'll just get stuck in it because there's no gaps. There's no fan assisting it. So convection is not the main method of heat transfer. Since particles can't escape or circulate, can't escape outside. And finally, it's they're saying it's painted black. The color black is a good emitter of heat energy. Right, that'll cover all the points, so that's them two done. Right, this is the bit that I was interested in, but it's good to know this, you know. I would advise you to learn this. These are nice questions because and just engage with the mark schemes. So I would always say to you, write it out in, so power is voltage times current. Right, or you could say, I think I've remembered it as PIV. Power is current times voltage, PIV. Right, small computer has a voltage of 5.1 and a current of that. Calculate the power. So then that's just straightforward. So we've stated the formula, and then you just substitute it in and give the unit. So right, the keen on you now doing that. There you go. Right, we'll call it quits at that for this. We'll do the next question on the next video.